Okay, so in this part of the review, we're going to look at the perimeter and area of trapezoids. So to find the perimeter of a trapezoid, you just find the distance around the outside of the shape and add those together. So you would just add like the segments or the sides of the trapezoid, but you wouldn't add the inside, so you're adding the distance around. So if I was going to do number 10, I would add 10.6 plus 16.4 plus 10.6 plus 24.8, and that would give me the perimeter. Now, to find the area, we want to use the formula for area, which is you're going to do a half times the height times the sum of the bases. So in other words, you find the average of the bases times the height. So if I was doing number 9, for example, the height is actually one of the sides of the trapezoid because I have this right angle. So I would do a half, to find the area, do half times the height, which is 9, times the sum of the bases. So I'm going to add 12 plus 18. The bases are the ones that are parallel. So then that would be 135 feet squared. And that's how you would do number 9. And the number 10 is just like it. So now let's look at circles. So for circles, you're going to find the circumference and the area. Now the circumference is the distance around the circle. The distance around the circle. So the circumference is distance around. So to find the circumference, one of the formulas that are on our formula sheet is the circumference is 2 times pi times the radius. So the radius is the measurement from the center of the circle to the circle itself. So in the case of this first circle here, 15, it would be 1.5 inches. And my pen here, my stylus, is giving me issues where it keeps going a little too high up, so sorry. So it's 1.5 inches. Now at number 16, they're giving us the radius. This is 2 meters. The hole diameter would be 4 meters. So the radius is 2 meters. And in number 17, the diameter is 7. Well, the radius is half that. So that's why the radius of the circle is 3.5 feet. So now that we have the radius for each one, we can use our formula to find the circumference. So to find the circumference, we're just going to multiply 2 times pi times the radius. So in number 15, I would find the circumference. I'm going to do 2 times pi times 1.5. So when I do that, I get 3 pi. Because I multiply 2 times 1.5, and that equals 3, and then I'm going to multiply all that by pi. So this is the most exact answer, but we are been estimating these, and I could use 3.14 for pi, and then I would have. So I got about 9.42, but I'm gonna round that to the nearest tenth. So it's about 9.4. So 9.4 inches is the circumference. So that's how you find circumference. How do you find area? Well, our area formula, and I'm still on number 15 by the way, our area formula looks kind of like the circumference one, except instead of multiplying by 2, we're going to take the radius and multiply it by itself. So the area is pi r squared, or pi times radius times radius. So we're multiplying the radius by itself. So that means in the case of our circle from number 15, so we're going to do pi times, and the radius is 1.5 times 1.5. So that means that our area is going to be 2.25 times pi. And then if I'm going to estimate that by multiplying by pi, I would get, so I get 0.765. Now, if I go back in time, I remember I'm really only accurate out to one decimal place. So I'm going to say that this is about 7.1 inches squared because it's area. So I had, for number 15, we have a circumference of 9.4 inches and an area of about 7.1 inches squared. So that's how you use the formulas for circumference and area. So you can continue using the same idea for 16. So as long as you have the radius, you can just plug it into the equation. And now let's finally look at this word problem. Melanie purchases a circular above ground swimming pool. There's the pool. There, it's great, isn't it? And there's some water in it. All right, she needs to clear a spot on her yard for the pool. So underneath here, in her yard, she's going to clear a spot. She knows the circumference of the pool is about 60 feet. How wide is the pool? So if the circumference, if the distance around the pool is 60 feet, and they want to know how wide it is, remember circumference, so the circumference is 60 feet, okay? And they want to know the width. Well, the width is the distance across, okay, which is the same as the diameter. So how do we how do we go from that into finding the diameter? Well, if I know the circumference is the same thing as 2 times pi times r, and I know that the circumference itself equals 60, I can solve this equation for r, and then I can solve it. Well, but I should also keep this in mind. The how wide it is actually not just r, but 2r. So what I really want to know is, what does 2r equal? So I'm only going to divide away the pi. I'm going to divide away pi. So I'm going to find out that 2r equals, okay, so when I divided 60 by pi, I would get 60 over pi. But if I estimate pi to be about 3.14, if I do 60 divided by 3.14, I get about, this should be about 19.11. So I'm going to write that again. So when I divide it by pi, what's left over? I have 2r, which is the same as the diameter, is about 19.11. And considering our information, I'm going to round that to the nearest whole number. So that means the diameter is about 19 feet. So if I know the diameter is 19 feet, or that 2 times the radius is about 19.11, then I can divide by 2 to get the radius. It means the radius is about, so when I divided that by 2, I got about 9.55 or something towards that. Okay, so then that would be the radius. So just one radii is 9.55. So now I'm going to find how many square feet. Well, square feet is area. So, and to find the area, I'm going to do pi times r squared. Now I know my r is around 9.5, and I know pi is about 3.14, so that means I can substitute in 3.14 for pi and 9.5, which is squared, for the radius. So that would be 3.14 times 90.25. And I got about 283.35 something, I don't know. Whatever it was, I was able to round it to the nearest tenth. and that's why I have 283.4, and that would be yards squared. So that's how we can do these trapezoid and area problems. Thanks.